Okay, so we're going to begin. So thank you everyone. Good morning for joining us today for a technical webinar on building automation control design assist, which is being facilitated by EmiratesGBC corporate member Trane. Thank you for joining us today morning. You'll have noticed that your microphone is muted, so I would kindly request if you have any question to submit, please use the questions box in your control panel on your right hand side. So I'm just going to start with a small introduction for the technical webinar. So my name is Jason John, and I work as a technical engineer for the Emirates Green Building Council. And I will be giving this small introduction in the start of our webinar. So for those of you members and partners who are joining us for the very first time for one of our webinars, I just want to give you a small introduction on Emirates Green Building Council. So the Emirates Green Building Council was formed in 2006 with the goal of advancing green building principles and ensuring sustainability in the UAE. Our vision is for the UAE to be a global leader for sustainability in the built environment. We do this basically by acting as a catalyst for collaboration and a hub for excellence to promote sustainability of the built environment. The webinar that you are participating in today is one such program that we run, which is to build capacity and raise awareness of our members and partners and also the wider industry as a whole. So just a bit of housekeeping for everyone joining us. So during the webinar, all your microphones are muted. There will be no verbal questions during the webinar. If you have a question, please submit them via the question box on the control panel. We at the Emirates Green Building Council, our technical team, and as well as the facilitators from Trane will be monitoring the questions as they come in, and we'll try to answer them when we can in the chat box privately or with the entire audience. And if it is a part of a larger question, then we have some time towards the end of the webinar to address any sort of pending questions. So if you have any pending questions, please bear in mind that we'll get to it towards the end of the webinar. So a few things about the webinar as well is after the webinar, we'll be sharing the recording of the presentation. So please allow about 4 or 5 hours before we send out the presentation recording. The one thing I would ask you to do is as you exit the survey, as you exit the webinar, you'll be directed towards the survey. Please fill out that survey so that we can continue to make more engaging webinars for our members and partners joining us. And lastly, please follow us on social media, EmiratesGBC, and post the webinar using the hashtags EGBC webinar and hashtag Let's Get Technical. And with that, I would like to introduce you to our facilitators for today from Trane. So first we have Saeed Allaham, who is the strategic accounts leader from Trane. He has over 25 years experience in air conditioning and the refrigeration industry. His diversified experience in Canada and Middle East include design and project management. He is lead accredited professional, certified energy manager, and all qualified professional. He joined Trane UAE in 2009, and since then he has worked with design engineers and consultants to develop innovative and energy efficient sustainable solutions. Also joining from Trane is Ahmed Maruz, who is the NG Services and Controls Director. Ahmed has over 15 years of diverse experience in the HVAC and building management system industry in both the US and the Middle East. He is a lead accredited professional and helps consultants and building owners design and execute sustainable and highly efficient HVAC and building systems. He has worked with major HVAC and control manufacturers in the market, and he is now part of Trane Technologies. So with that, I am just going to hand over to our facilitators for today. Let me see if we have perfect. We have Saeed on the call. All right. So Said, I'm just going to hand over control to you.
Thank you, Jason. I'm Ahmed here. Thank you, everyone, for attending this webinar, and hope that we can provide something that's useful for you and can make your work more effective. Today, we're going to talk about a subject that we've been talking about for a long time, and we've been emphasizing the importance of giving accuracy on this specific task. So we're going to talk about designing building management system or any control system you have for a chiller, for a chill plant, for any HVAC system that you have in your building. Normally, when we talk about this task, it's kind of a time-consuming task that we spend a lot of time trying to build, design, or let me put it this way, we try to put consistent and accurate design for building management system. With the time pressure we have, with all the responsibilities we have on a daily basis, normally engineers or designers, they don't have time to spend a month or two designing a building management system from scratch. So what we're seeing in the marketplace, that normally everybody uses whatever they've built before for any other project and modify it and try to provide spec in no time. And that's putting a lot of pressure on the consultants, on the clients, on everyone, because to do this and to provide something maybe not as consistent or as accurate as we want to be is not what we all want. It affects everyone, starting from the designer all the way to the contractor who executes the project. So we've at Trane, we've come up with a solution for this, something called Trane Design Assist. Trane Design Assist is the web application that we launched in 2019 that automates this process. Normally, we used to do it manual, which created a lot of inconsistency. Not everything was matching from the drawings to the data point schedule to the specs. So what we decided to do to make this process, and we make it self-service. So anybody can go online and build his own design with this tool. So if we just dig deeper into this, so the three benefits or three features of this tool is three things. So first, you can design everything from scratch in no time. So instead of spending weeks or months trying to put the accurate design, you can spend a day or two just to complete the whole design. The second thing, specifically in building management system, we get inputs from different stakeholders. It's not only one engineer or one consultant that designs the system. We get the inputs also from other departments. For example, you get mechanical engineer on board, you got electrical engineer on board to get the inputs to make sure that you have the right design from a mechanical and electrical perspective. The second thing that I also wanted to do, that you can publish this or get the right documents in any formats that you want to either modify them and then flow the tender, or to take them in PDF or format that you can throw it in the tender right away. It's simply, you need just to create an account. You go to we will provide the link for this after the call. I believe Jason will send it along with the recording that we'll do here. So you go to that link, you click the link, it takes you to that screen that you're seeing in front of you. The way you start is you click on create an account. Once you click this, you have just three simple information you provide: your email address, your first name, and your last name. And here you go, you're in the tool. Once you give this information, you have your own account and you can go right away and use the tool. Here's a sample of how it looks like when you have a project, you build a project here, or design a project. As you can see here on the left side, that's the project design tab. You have on the left side the project hierarchy, the building you have, the equipment or the systems you have. You have in the middle here all the icons that you can drag, just drag. So you click, for example, Tanko unit, and you drag it in the canvas, and then you start configuring using the right hand side, which is the configuration where you can configure anything to whatever requirements you have in your system. So simply, you go to that icon, you drag it in the middle of the screen, you click on it, and on the right-hand side, you configure it to whatever information you want. Once you finish this, everything here you do on this screen is reflected on the all other screens or all the other tabs that you can see down there. So you have the project design. Once you finish it, it goes to the flow diagram. You can see here that's a sample of an HU flow diagram that's built automatically based on the inputs you put in the project design canvas. So you get this information as either AutoCAD drawing or any other format that you want. Go to the next one, which is a sequence operation. You have here a generic sequence operation where you can modify it also to get in Word format or PDF, depends on the requirements. So in a Word format, you look at it. We built everything here as generic. So something that I really want to highlight here is this not specific to Trane controls or Trane building automation. That's a generic tool that can build generic design. So this design, you can, it will not, I would say, put or make it specific for Trane. It can be open for other manufacturers as well. So once you get this sequence operation, flow diagram, guide specs, and points list, they're all generic. You can use them, and any controls manufacturer can bid on this project. And then you have the guide spec, also a general guide spec where you can modify or add or do whatever you want with the document and then flow to the tender. And then you get the points list. Points list, as you can see here, on the left-hand side, you have the point description. On the right-hand side, you have the points themselves, the type of points, whether it's digital input, digital output, binary input, analog input, all the types of points. And then it's reflected also, you're not doing anything here. It comes automatically based on the inputs you put the project design. Again, I want to go back to the point of consistency. Normally, when we go back to revise specification, sometimes we revise the data point, but we don't revise the flow diagram. We revise the flow diagram, we don't revise the sequence operations. So these tools give you consistency all the way, starting from all the flow diagram all the way to points list. And also something that we get feedback from consultants that they do a lot of revisions. So normally when you do a lot of revisions, the client comes back to you, tells you, we need to do this 1, 2, 3 in this project. So please revise the drawings, revise the data point, revise everything and come back to us. With this tool, you can go back to your project and modify whatever you want in the project design, and everything is reflected in the other tabs. So you get a consistent and accurate design for your project. Something also I wanted to highlight here, that's a free tool. Anybody can go and access this tool from any computer you have. You can go and build your design. There's no fee, there's nothing. It's a free tool for everyone to access it. That's the link that Jason will send along with the recording to everyone. And again, this link, you just click the link, create an account, put email and your name, and that's it. You're good to go. With this, I will hand over this to my colleague Saeed Al-Laham to walk you through a live demo where from scratch how you build your own design for your building controls. Thank you so much.
Thank you, Ahmed. Good morning, everybody. Thank you, Jason and EGBC staff for arranging this webinar. We really appreciate your efforts to help the industry and the consultants. And we thank you all for your time and for your interest to attend this webinar. I will take you through a tour. Please bear with me. Okay, so this is here the web address for the link. And here you can create an account, as Ahmed mentioned, by entering the email and the name, and then you can create an account. Now I have already an account, so I will sign in, and we will start right away by showing you the tool. So once you open the tool, you get this help. So the first tab is to create a new project, and here you have the list of the projects that you have in the system. This is here, you can, for every project or for every file, you can save as, you can share. So by linking share, you can share with your colleagues. So you can share all the data files, so multiple people can work in the organization on the design, like the mechanical engineer and the controls engineer. So it's good for the collaboration. This is easy for sharing. Edit, you can edit here the project information, or you can delete the project. Once you tab here, this is my projects. If you have some specific or custom made, let's say, design, you can contact Trane for the special design. And this is here the terms and conditions. If you click here on the Trane tab anytime, it will it will take you to the user profile and to the project. And this one here is the user profile and also the logout. So let's create now a new project. Let's call this project, for example, GBC example. And we can enter the description like this is a commercial building, G plus 20. And then now we are creating a new project. Okay, now once we create a new project, now we have here the design Canva, as Ahmed mentioned. Now we have here the facility type, we can enter. So we can drag a building onto the Canva. Now we can call this one East Building. We have how many quantities? We have one. And the configuration, we can specify the type of the control. Is this a new building or this is an existing building? For example, let's say this is a new building. And let's say the communication, we can say backnet, non-Modbus, let's say backnet. Do you want control through iPhone or tablet or no? If you want, let's say control through iPhone and tablet, provide local operator. You want local operator touch screen, no? And we configure, for example, the first building. So we have now here a building. Now we'll go to the systems. We have cooling plant systems. We have heating plant systems. We have VAV systems or VRF or water source heat pump. Many things to go through, but we will go with the most common and required, let's say, in our region. So we will go through cooling plant system. So now we have here a cooling plant system. So now we have here direct cooling source. So we have to identify the cooling source, either air-cooled or water-cooled. So we want it air-cooled. We will see another example with water-cooled, but let's start with the air-cooled. Air-cooled chiller. Chiller quantity, how many chillers we have? Let's say we have 3 chillers. The flow that is going to the load side, is it constant flow or variable flow? Let's say variable flow, which is more common. A chilled water configuration, is it variable primary or primary secondary? Let's say primary secondary. By doing this, you are making here the configuration of the control for the cooling plant system that you have. how many secondary pumps you have, 1, 2, 3, or let's say we have 3 pumps in the secondary. Here you have chilled water pump pressurization. Let's say no to make it simple. Minimum water flow, let's make it no. I just want to make it simple now, and then later we can change to see what is the meaning of these ones. The beauty of this tool is that it is intuitive. Even though that these, let's say, items can be not clear for you in the beginning, with working with the flow diagram and sequence of operation and specifications, you will get to know more familiar with the details of these items, as we will see. Specify new cooling controller. Local operator interface, we want display, we want mobile app, we can choose no, equipment communication, backnet, or any other communication. And here you can say 3 approved manufacturers, or you can select 1 manufacturer. So we finished the configuration for the cooling plant system. We can go to the flow diagram. And we see here, in the flow diagram, we see here 3 chillers. We have 3 primary pumps. We have 3 secondary pumps. And we have here, since the pumps are controlled by variable speed drive, we have here the pressure sensor or transducer, which is controlling the speed of the secondary pumps. And now, whatever changes we make here, it will be reflected for here immediately. For example, chiller quantity. If I want to make, for example, 4 chillers instead of 3 chillers. So we will add here that we have 4 chillers instead of 3 chillers. So the change is happening here instantaneous, as we see here. We can change the number of the secondary pumps for example, 4 pumps instead of 5 pumps. So whatever changes you make here in the configuration, it will make immediate change in the flow diagram. Let's come to the sequence of operation here. And based on this configuration that we made here, we have the sequence of operation for the plant. It will start like by describing the systems, which is common, that we have 4 air-cooled chillers, we have 4 primary pumps dedicated, and we have secondary pumps. Here it describes the sequence operation for enabling the system or disabling the system, and the start-stop of the primary pumps. And in the case of the pump failure, which is like in 30 seconds, if there is no response to the contact, the second pump will start. And for the controlling the secondary pumps, the lead, lag, and standby, the control philosophy, and how does it start the second pump or stop the pump. It will describe here the control of the secondary pump variable speed drive, which is based on maintaining a pressure set point of 15 psi, for example, and this is adjustable. So all of that is generated automatically based on the configuration. For example, here we talked about chilled water pressure optimization, for example. And for example, I don't know what is that, so I will select, for example, now chilled water pump pressure optimization. And then now it came here in the sequence operation. So it talks about, let's say, a control philosophy when it's based on the pressure optimization of the system based on the valve percent opening. So you can, let's say, select something here, and then you can go through the sequence operation to know what that item, if you want it in the configuration or not. So I read it, I see here, I don't want that, so I will say no. Okay. Same here with the, for example, minimum bypass. For example, we selected here no. We go back to the flow diagram. Now, if I add minimum flow bypass diagram, you will see that here that it's adding now the minimum bypass flow to the system. So as we see here, it is intuitive. Based on the configuration that you make, all the changes that you make, it reflects immediately on the flow diagram and on the sequence of operation. The second one, we have the guide specifications, where it's based on the configuration. And then finally, we have the points list. So all of that is generated automatically based on the configuration that you made. Okay, so let's make another building. And we call this, for example, West building. We have 1 building, and for example, we want now a system cooling system for this building. And the direct cooling for this system, we will have it as water cool. Type water cool, chiller quantity, 2 chillers, chilled water flow, variable flow, water pipe configuration, primary, secondary. Now it talks about the secondary pumps. How many secondary pumps? I have secondary pumps. Optimization, let's say yes. Minimum water flow, no. How many towers? We have 2 cooling towers. Tower fan control, we have the variable speed or constant speed or 2 speed. Let's say we have 2 speed cooling tower. Condenser type, the condenser can be constant flow or variable flow. So based on that one, it will select the type of control. For example, we can have constant flow for the tower. We can make it variable speed. The condenser pump, it can be dedicated or manifold. Let's see the dedicated first, and then we look to the manifold. New cooling plant. So we are doing here the configuration of the cooling plant. And then we come now to the flow diagram. So we see here, based on our configuration, we have here the cooling towers, we have here the pumps for the condenser side, we have here the chillers, we have here the primary pumps, we have here the secondary pumps, and we have here the design. And whatever change we make here, it will be reflected. For example, the condenser pumps. We selected here, for example, dedicated pumps. So you see here, every chiller in the condenser, it have its own dedicated. We can select manifold. And when we select manifold, then it will ask me how many pumps we have in the condenser. For example, we can have 2 condenser pumps. And as you see here, it changed the design. It removed the pumps from here and put it in manifold configuration. And then we have the sequence and the guide specifications. And we have also the points list based on that. Okay, so now we have, go back to the project design. We have here now 2 buildings. Okay, each one is having a plant. I'll show you like how to publish that one now from the design, and we want to publish this data. And after that, we will talk about the equipment control and the airside. So let's see how we publish that project information. So what do we want? We tick here what we want to publish. We want to publish the flow diagram, the sequence, specifications, and points list. You can edit that one in many formats as drawing or PDF or docs. So let's say here, PDF. You have the option of extracting or exporting the documents as one single write page or multiple standard size. Let's put it as one file for the time being, but you have the option. And let's generate documents. Please bear with me, it takes some time. Okay. So we have here, now this is the output file. Now we have here 16 pages. We have here. So we have here the water cooled chiller plant. We have here, we zoom in. We have here the sequence operation. We have the guide specifications and the input output diagram. This is for the first cooling plant that we did. And this is for the water cooled plant. So all of the design documents in one folder. You can select, instead of PDF, you can select AutoCAD format, and you can select also multiple files. Okay, let's go back to our tool, and as we mentioned, if we click here on the Trane logo, it will take us to the project that we have. Our project is the EGBC example. So we have here 2 buildings. Now let's look to the air side. For example, in the west building, we want to add an H. And we can select HU-1, quantity HU1 and 2. Quantity we have, for example, 2 HUs. Select the configuration of the H. It can be constant volume, variable volume, or single zone. Let's make it variable volume. Outside air configuration, if we have outside air, fresh air 100% or mixing, let's select it with mixing. Building pressure relief, let's say no relief, that the relief is done separately, not by the AHU. Outdoor airflow, yes, we have outdoor airflow. A preheat, we don't have preheat. Cooling, what is the type of cooling? Chilled water or DX, let's say chilled water. Reheat, let's say we don't have reheat now. Economizer, if you have economizer, let's make it simple, this one, and make it no economizer. If you have any questions, please go ahead, type your questions, and we'll take your questions. Demand ventilation, if we have no demand ventilation or based on retained CO2 or retained CO2 sensor or space, let's put retain. Fan airflow, let's say yes, monitoring, we want to monitor the fan. Mixed air sensor, yes, we want to sense the mixed air sensor. Low temperature thermostat, no. And space sensor, let's say wireless. Smoke detector, I'll put it now no, and then later we'll change it. And now we come to the flow diagram. So now we have here a flow diagram of AHU, we have here the return, we have here the fresh air, we have here the cooling coil, we have here the fan. This is the CO2 sensor because we selected the return. This is here the fresh air and the dampers, and this is here the cooling coil. This is here the limit thermostat, and so on. Now, as we mentioned, also like what changes we make here, it will be reflected immediately here. For example, smoke detector, I put no. I can put smoke detector on the supply and return, or supply return. Let's put both of them. So as you see here, it added smoke detector on the return on the supply. So whatever changes we make here, it will be reflected. Let's look to the sequence. So it will have the sequence of operation for the AHU based on the occupancy, based on the sensors. And so now we have the guide specifications and we have the points list. We go back to the project design again. And we can also, now we have one building. Let's say we'll go to the facility type. And if we have a campus, for example, I have, let's call this one, let's say call it University in Dubai. Okay, and let's say that this is a campus. Let's say this building, instead of calling it West Building, let's call it, let's say, College of Engineering. And for example, this College of Engineering is part of the campus, so I can put that one in the campus. So now I have a university which is campus, and for example, this East building, I can call it, for example, College of Medicine, for example. So I have another building, and this building I can also put it in the campus. Now I have a campus. So you can have here in the design canvas, which will showing you the hierarchy or the architecture, where you have a campus and buildings under that one, and also in this here you will see also the hierarchy of the buildings, which is under that one. We can look also for more systems. Let me, for example, go to College of Engineering, and I want to add example of fan coil unit control. We saw the AHU control. We can make it more complicated. I just want to look to a fan coil unit. The fan coil unit control is simpler than the AHU, so we can put here an FCU, and then we can configure the FCU. How many FCU we have? We have, for example, 20 FCUs. We can call this one. FCU, the typical one, like 20 FCUs. If we have any note, we can, the configuration, airflow configuration, retain air, no mixed air, coil configuration, cooling only, or cooling preheat. Let's make it cooling only. Make it simple now. Cooling source, we have, for the valve, we have chilled water. Analog is normally for the big coils, HUs, two position for the FCUs. Fan modulation, let's say we have 3-speed. Low limit, let's say no. Smoke detector, let's say none. And then later you can change it. Okay. Condensate overflow, let's say yes. The fan status, we want to know the fan status. Filter status, we have differential pressure sensor or none, or timer, for example, none. Space sensor, it can be wired or wireless sensor. And now we finish the configuration of the control for the 20 FCUs. Now this is here the flow diagram for the FCUs. And as we mentioned, we can make any change here so that it will be reflected immediately in the diagram. We have the sequence and the guide specs and the points list. Now, if you have any questions, please post it, and then we will answer it by the end of this tour. I think with that tour, we went through most of it. There are also some auxiliary controls that you can add to the BMS system or for the control system. You can add, for example, gas meters. You can add lighting panels if you want, for example, to the building. If you have a lighting panel, you can drag it and add it to the system. Or if you have power meters, you can also add them to the systems, and they will, for example, if I come to the power meter. Now, power meter, I will not have, okay, I will not have any flow diagram. Come here to the, okay, so let me come to the power meter here. Now, I don't have flow diagram for the power meter. I don't have sequence operation for the battery, but I have guide specifications for the power meter. So now you have the specifications, guided specifications for a power meter, which is an auxiliary item, and then you can edit the specifications as you see. So as you see here, this tool will enable you. It's flexible. You can make any architecture or hierarchy of the buildings in a campus. You can even remove, for example, if you don't. For example, you have here 2 buildings and you don't have, for example, a cooling or chilled water plant for each building. You can remove, for example, this one, and you can have one cooling plant for the whole campus. You can also do that. You can, so it's flexible. You can make any hierarchy or architecture to the project, and it's also integrated, so it's comprehensive. So you can put all of the control that you want in one file, and it's all linked together. By this, I come to the end of the tour. I hope you find this interesting, and I hope you find it beneficial and useful. So we will take now questions.
Perfect, Said. Thank you for the wonderful presentation. Thank you, Ahmed, for the wonderful presentation as well. We've gotten a few questions that have come in, so I'm just going to read them aloud to you, and you can just demonstrate it whilst you're on the tool. So one of the questions was based on the hydraulic design. Can you get the graphic layout?
So the graphic layout is not available yet in this tool. So all what we have is the inputs or the outputs actually that we showed, that Saeed showed now. Point schedule, flow diagram, schematics, and specs, guide specs. That's what we have as an output now for the tool.
Okay. So even if they select the controller, they won't be able to select any sort of the graphic layouts.
Yeah, so you have the flow diagram, which is normally the practice, right, in the design for the builds. But the graphical design will be a kind of like higher stage where it can be done by the manufacturer. When it is based on, when you work, let's say, with the manufacturer, he can provide that a graphic design, but not at the stage of a generic tool where it's based, let's say, based on any type of the control or any type of the equipment. But once you work, let's say, for example, with a certain manufacturer, including us, he can provide the graphics design that you want.
Okay.
It comes with the stage of the project. Please, yeah, go ahead.
All right. Perfect. Someone had asked, how do you know the capacity of the chiller or the chilled water pump and the AHUs and so on?
That's not relevant to the control philosophy. Whether the chiller is 100 ton or 200 ton or 300 ton, that's part of the mechanical specifications and the equipment schedule and the design of the mechanical. But as far as the control and building automation system point of view, it will be the same control philosophy.
Okay. So yeah, so in essence, even if you have like 2 or 3 chillers, but as long as whatever's the capacity of those chillers is, the control system setup is still more or less going to be the same, whether or not it's 3 chillers of 100 ton or 200 ton, correct?
Absolutely.
Okay, perfect. Can the software show connections to BMS system when it is required in a project?
I'm sorry, can you repeat this again, Jason?
Can the software show connections to BMS system when it is required in a project?
Can the software system, sorry, say it.
Can the tool, the Trane Design Assist, show connections to a BMS system when it's required?
Yes, actually, if you saw in the when Saeed was doing the live demo, there is actually a PC where you put the software and you show the connection with the HVAC system to the BMS. Yes, it's there, the tool.
Okay, and there are different options in which you can configure it on the communications, right? So on the communications, you only show the backnet, but then there are other possible configurations that you can choose from again, right?
Yes, and it is in the drop down. You have like the backnet, you have the long talk, Modbus. So there are different communication.
All the common protocols are
all the common protocols. Okay. Perfect. There is another question. They're saying the maximum chillers that you can select in the secondary and the cooling towers. The maximum we can select is like 5. What if you want to specify, or you want to select more?
Yeah, it's actually 4. So as per the software, the maximum number of chillers are 4.
Okay.
Yeah, if you have more than that, it's not in the software tool, but we are ready to assist on that. I mean, like if you work with Trane or any other manufacturer, he will make more customization for that for the chillers. Basically, it will be the same concept of sequence of operation, but with the tool we have the maximum of chillers 4.
Okay. Is it possible to change or edit the sequence of control?
Yes, it is possible. You can export it instead of as a PDF. You can export it as a drawing, and we expect, of course, the design engineer to go through, for example, the sequence of operation, which is the standard one and which is the automated one. And based on that, let's say if he wants to override or he wants to change something, yes, he can override it and he can edit it and change it. Absolutely. Yeah. So okay. The software will give you, let's say, the standard control philosophy and sequence operation, which is common in the industry. And if the design engineer has some specific or definite purpose to override the sequence operation or specifications, of course, he can do it.
Perfect. And the option to add airside equipment, I believe you already covered the airside equipment, right? On the AHU, the FCUs that you can add.
Yes, AHUs, FCUs, yeah, that option is there, and Saeed already demonstrated that option in his live demo.
Perfect. So I think with that, we have reached the end of the question list. Anything else that was, or some of the questions that I have not addressed, they were already addressed in the webinar during the live demonstration, and we'll be sharing around the recording of the webinar to all the participants here today. So please allow for about 5-6 hours when the recording is available, and we'll send it out across to each and every one who's registered and participated in today's webinar. So thank you so much, Ahmed, Saeed, for your time and for your support as well of sharing this great and wonderful tool. I think it's a real asset for anyone in the industry to have a free tool that has such capabilities and functionality made available.
Thank you, Jason, for your efforts. Thank you all for your interest and for your time. We really appreciate it. And don't hesitate to contact us if you have more questions or inquiries. We will be happy to respond to that. Thank you so much. Thank you all.
Yes, exactly. And if anyone has any questions, please get in touch with us, and I am happy to share around the email addresses or the contact details of both Mr. Saeed and Mr. Ahmed in case you want to know more about the tool itself, or we have any other questions that you may want to ask them directly. So please feel free to get in touch with us. I'll be in the emails that I'll be sending around. You will find our contact details as well as the link to the tool that was demonstrated today, the Trane Design Assist. The link will also be there within the emails that we'll be sending out. So please keep an eye out for that. So thank you everyone for joining us today. Yes, the tool is free. For everyone who's concerned, the tool is free. All you need to do is just register yourself, your email address, your first name, last name, and it's absolutely free for anyone. So with that, thank you everyone for joining us today morning. I wish you a very good day.